Number 1, the first part you're supposed to do is draw the free body diagram. So first it has the force that already has it down, but you put that under here. And then it also has the weight, but the components of it are mg cosine theta. And then on this side would be mg sine of theta. But like it would also be the weight, which is here, which can be here, but these are just the components. And then it also has the friction force, which would be static friction because it's not moving. And then here's the normal force, and the normal force is also equal to mg cosine of theta. For the Newton's second law is that force is equal to mass times acceleration, and then we want to break it down to the axes. So the net force for the x-axis would be, you can look at the free body diagram while you do it, so you would be able to see. So you would have mg sine of theta minus the force of friction, because these are both on the x-axis, is equal to 0. And the reason why it's equal to 0 is because it would normally be mass times acceleration, but since it's not moving, it would be 0. And then for the y-axis, you can look at it the same way. So it would be the normal force minus the force adding on to it minus mg cosine of theta is equal to 0, and it's 0 for the same reason. And then for value of F that you would need to make the whole system stationary is you can just solve for F. And if you look at both of the components, you can see that they both include the normal force, because you can rewrite the components of x as mg sine of theta times, and this is how you can write the friction force instead, which is the coefficient of friction times the normal force, which is equal to 0. So then you can solve for n, which is mg sine of theta over mu, which is the coefficient of friction. And then for the y components, you just have to move all this over, so then the normal force would be equal to the force added on times mg cosine of theta. And then you can just set both of the ends that you solved for each other equal to each other. So you'd have force plus mg cosine of theta is equal to mg sine of theta is equal to the coefficient of friction. And then you can solve for the force, and then this is what you would get after you move all of the variables around. And then you can just plug in the information that you get from earlier on in the problem, because they give you all of this, and you can just plug it all in, and then you get 19.9 newtons. And then for the last problem, it's talking about after you take away that force, so you no longer have that extra force added on in your free body diagram. And acceleration would just be the F net over mass, because you can just rearrange the F equals ma. So then you have F net now is only equal to, because these cancel out, it'd only be mg sine of theta minus mg cosine of theta times the coefficient of kinetic friction, because it's moving now. So we're only looking at this plane because these two cancel out, over mass. And then you can take the mass and gravity out of the equation to make it more simplified. So, and then you can cancel out the masses. So then you're only left with gravity times sine of theta minus cosine of theta times the coefficient of kinetic energy. And then again, you can plug in all of your variables, and you gotta make sure your calculator is on degrees, and then you would get 2.54 meters per second squared is the acceleration you'd get for the block going down the inclined plane after they release the force.